Okay guys, Timmy coming at you here again, and today what I want to do is I want to go over the concept of pH and why it's important. Now remember that the goal of the body is to maintain homeostasis, right? So one of the things that has to be maintained is the pH of the blood. Blood pH is critical. And the blood pH has to be maintained between 7.35 and 7.45. Now, that may not mean a lot right now, so let me explain it. First of all, when you talk about pH, what you're actually measuring is the amount of free-floating hydrogen ions in the blood and bodily fluids. So some of you may work in a doctor's office or a hospital, that's Spanish for hospital, and one of the things you have to do is measure the pH of urine. And the reason that's important is, to a doctor, they can tell based on the pH of the urine kind of what's going on in the blood. Now, so remember, pH is a measurement of free-floating hydrogen ions in the blood or bodily fluids. And when we talk about pH, we only talk about free-floating hydrogen ions. So any substance that gets dissolved, any substance that gets dissolved in bodily fluids. Blood's a bodily fluid, right? You don't bleed dust. And produces free floating, that's just floating, hydrogen ions equals an acid. Alright, so let me give you an example. There's this stuff, when you combined hydrogen and chloride, you get what's called, you're not going to believe this, hydrogen chloride. Alright, now remember that when substances that are held together ionically, right, those are weak. So they're held together weakly. When they get dissolved in bodily fluids, the water will break those weak bonds apart, right? So when hydrogen chloride gets dissolved in bodily fluids, it produces free-floating hydrogen ions and free-floating chloride ions. And what did I just tell you? Any substance that gets dissolved in bodily fluids and produces free-floating hydrogen ions is an acid. So hydrogen chloride in the body is actually hydrochloric acid. So again, and this is the simplest definition I can come up with, any substance that gets dissolved in bodily fluids and produces free-floating hydrogen ions is an acid. Now, one of the things you have to understand too is looking at the pH scale. It should be straight. I'm left-handed. And the pH is actually measured on a scale of 0 to 14, where 7 is neutral. Now, this is what I want you to understand. As the amount of free-floating hydrogen ions increases, in the bodily fluids. The pH goes down, the number goes down. So if you put in 1, 2, 3, 4, 5, 6, 7, yeah, I did it. All right, so if you look at a pH of 5 compared to a pH of 2, which one would have more free-floating hydrogen ions? Well, the pH of 2 would. That's because as you go down the pH scale, the amount of free-floating hydrogen ions in the body and bodily fluids goes up. So the higher the number on the pH scale, the less free-floating hydrogen ions you have. So when you go above 7, that means that the amount of free-floating hydrogen ions is decreasing. Now, I know it's a little counterintuitive, but you're going to have to deal with it. Otherwise, I got to give you a math equation, and that could lead to some trouble. So, what's the idea here? Here's the idea. pH is a measurement of free-floating hydrogen ions in the blood and bodily fluids. The pH of the blood has to be maintained between 7.35 and 7.45. I'll explain that in a little bit. What's the definition of an acid? Any substance that gets dissolved in bodily fluids and produces free-floating hydrogen ions, this is a hydrogen ion, equals an acid. So one of the examples I gave you is hydrochloric acid. Here's another example of an acid. Yeah, okay, I'll keep that. Right? And this one's really important because this is acid-base balance in the body. Boy. This guy right here is called carbonic acid. So what happens to carbonic acid when it gets dissolved in bodily fluids? Dissolved. Well, it's going to form free-floating hydrogen ions and these guys. And this guy right here, you're going to need to learn this, called bicarbonate, or bicarbonate, when I say bicarbonate. That's another example of an acid. Why? When it got dissolved in bodily fluids, it produced free-floating hydrogen ions. Now, the question that should come to you, your mind, is why does the pH of the blood have to be 7.35 to 7.45? Well, before we discuss pH, we were talking about organic compounds, right? And remember, I told you that the players of the body, the dudes who do most of the work in all the cells of your body, are amino acids. And remember, you have 21 individual amino acids in your body. And if the cells take amino acids, I'm making this up, if you take amino acid 2, If you take amino acid 2 and combine it with amino acid 4, and then combine it with amino acid 8, and then I'm making this up, amino acid 12. When you chemically bind, you form a chemical bond between amino acids, you make a protein. And the proteins of the body that control all the chemical reactions, you should remember this, are enzymes. So what are enzymes made out of? Proteins. What are proteins made out of? Amino acids chemically bonded together. Now, individual amino acids carry an electrical charge. I'm making this up. And when those charges interact, when you string those amino acids together, it's going to form a particular shape to the protein. I don't know how it would work. I'm making this up too. Doesn't matter. Right? So enzymes are kind of like the locks or the keys to the locks that you have on your house or your car. The key has to fit. The shape of the key has to fit the lock. Otherwise it doesn't work. Now, what controls all the chemical reactions inside the cells of your body? Enzymes. So they're little workers inside your cells. What's important about how an enzyme works? Its shape. Its shape determines its function. So if you alter the shape of this enzyme, you will affect its ability to do its job. And you're not going to believe this, but because proteins are temperature and pH sensitive, they maintain their ideal shape at 7.35 to 7.45.